All right, today we're talking about factoring, and one of the good methods of factoring a equation is this method called factoring by grouping. It's commonly used when we have four terms, and there is not necessarily a GCF that is readily available to pull out of all four of those terms. What we want to do is we want to group two of each of these terms together in their own sets of parentheses, and then we're going to look at that group individually and see if there is a GCF. So in our first group, the 5v cubed minus 3v squared, we have a v squared that is in common in both of those. And then if I pull a v squared out, that would give me 5v minus 3 left over. Now when I look at the second group, the 40v minus 24, we could pull out an 8 from that, because an 8 is in 40 and an 8 goes into 24 evenly. And when I pull out an 8, you'll notice that I am also left with a 5v minus 3. Now this is a really common thing with factoring by grouping, and if it didn't happen, then you couldn't factor this any farther than what we've already done. But you do notice that the 5v minus 3 is the same as the 5v minus 3 on the other side. And what we can do is pull that out as basically a binomial GCF. So I'm going to say what this whole term has in common with this whole term is the 5v minus 3. So I'm going to pull that out in front, just like I did with the regular GCF. And then I'm going to say, well, what is left over from the first thing? Well, the first thing had a v squared left over. And what is left over from the second thing? Well, the second thing had an 8 left over. And that would be the end of my equation. You can see that if I were to use the double distributive property, I could distribute the 5v minus 3 to both of these two terms right here, and I'd end up with the step above me. Now this is the fully factored version of this type of equation, because neither one of those things has any GCFs or anything left over in them. If we look at another example, this one right here, it's kind of a little bit different. If you group this together, what you want to do is you want to make sure that you keep that negative sign grouped in with the second object there. That negative sign is important. It is a negative 20n, so we put a plus in between them just to make sure that we emphasize that that negative is on the inside. Because if I put the negative on the outside, I'd have to distribute it, which would make this 5 into a negative. So we don't want to put it as a minus, the second group. The negative has to stay on the inside. Looking at the first group right here, we could pull out a 4n squared from both of those terms, which would leave me with 4n minus 1. And then if I look at the second group, you see that I have a 5 that is in common. So I say pull out a 5, which would leave me with a negative 4n plus 1. Now if we look at our leftover pieces, our quotients as it were, we have two things that are very, very, very similar to each other, but they are not the same. That is just because we didn't really pull out a good GCF from the second group. If you notice, I could pull out not a positive 5 from there, but I could pull out a negative 5, which would change this to a positive 4n and a minus 1. That's a really good thing, because then that will make my leftover stuff, my quotients, the same. And then I could pull that out in front like the binomial GCF that it was, 4n minus 1, leave me 4n squared minus 5 left over from the originals. That would be how a fully factored version, because neither one of those binomials that are left can be factored any farther than this.